to cloud. All right, so most of you should now get a, is it okay to record message? And so here we go. All right, my name is Andy Lindsay, and this is the What's a Microcontroller with Python and the Microbit 2.0. It's the first day of 3 workshops on Monday, Wednesday, and Friday, November 15th, 2021, starting at 1 p.m. Pacific time. As I mentioned, I'm Andy Lindsay. I've been working for Parallax for about 21 years now. My training is in electrical and electronic engineering, but when I started interning at Parallax, actually, they had me working on textbooks for electronics education, electronics programming, robotics, and so I ended up writing about 10 textbooks over the, well, 10 and counting textbooks over the following 10 years. And after that, we started doing deploying our textbooks on the web. Some of the more recent material I've been working on is the Cyberbot. Now, I didn't write the textbook per se. It's a derivative work of an earlier textbook I wrote that was posted online for the Cyberbot. And so this is what the Cyberbot looks like. And it's an educational robot that we'll talk about on day 3 when we go over the curriculum and the relation of what you know, how to mix and match, what works best as a sequence, et cetera. We'll have some discussions about that. And then today's topic is the What's a Microcontroller with the Microbit, which I have a little excerpt from it right here. I put some of the previous workshops from the Cyberbot, their YouTube recordings, and then likewise the previous workshop of this. I hope to make this one a little bit value added, so please don't disconnect now and run and look at YouTube, because I think we'll have some better material than my previous recording. About Parallax, that's the company that is that I work for, and that has been responsible for the material that you'll be working with today. I'm right behind this window in the corner right here, and we have about 20 employees, and pardon me for stammering here. And so Parallax got started with microcontrollers. Now, microcontrollers are the programmable brains that are inside many of the products you use on a daily basis, but they're also, of course, used by students for invention. So the distinction normally between a microcontroller and a computer is when you start up a computer, it has to load an operating system, and then it has some kind of environment that you work in. Whereas a microcontroller is just a chip that's designed to talk with other electrical and electronic parts inside these inventions to automate them, to give them a display, to monitor the push buttons and stuff like that. Chip Gracie and Ken Gracie are the, well, Chip started Parallax and Ken has been running it while Chip does the majority of the inventing. One of Chip's earlier inventions was the basic stamp microcontroller. This is the second incarnation. The basic stamp showed up around 1995, and it really turned electronics hobby and electronics education on its head, because this was the very first microcontroller that you could get and connect to circuits and program in a simple language and have immediate success. Before that, it was very much more an engineer and skilled technician only game. And so this completely leveled the playing field. Everything started over from scratch. Now, 25 years later, the Microbit is one of the cooler microcontroller modules that has come out recently, and it's especially useful in education. And so what I did here is I included some links, and I actually need to go back and paste you the link to this slideshow, because I'm hoping that you will use this slideshow as kind of a reference back to some of the things. So let's see, I need to get to my chats. Here we go. And everyone, all right, so I just pasted in a link to this slideshow. And it has a lot of links that I'm hoping you'll save for future reference. For example, this beating heart one, it's right out of the microbit.org/project/make-it-code-it. And so you can click the picture and it'll take you to this Make It Code It project. And in this particular project, you can go and edit it and make code blocks, which actually also gives you JavaScript and Python coding options and some virtual microbit and debugging. Or this is the Python that we'll be using today. And so you can use the same environment that we'll be using. So open in Python and preview. Here's the environment we're using. And I'll get back to this later. Now, if you're curious or if anything about, seeing this and seeing all these fun little applications like a step counter and a compass and radio communication, sending a smile, sensing sunlight, entering whether you're happy or sad using push buttons. All of these are microbit only things that can be part of a predecessor to the material that we're doing today. It's great practice. It's great warm up. It gets the students really enthusiastic. And so just recently, I did two 2-hour workshops that are microbit only and that take a very deep dive into all the resources that are available for that kind of learning on the microbit.org website. And it covers the make code blocks. It covers remote deployment of remote classrooms for students, the various curricula that's available, and a lot of just simple how to utilize the simulator and its built-in debugging tools. So here are links to the 2 workshops. You can follow those at your leisure. And also I put in a link to the slideshow for that. All right, so today we're going to do intros and overview. I think we got through the intros, so overview is up next. We'll talk a little bit about the homework that went out before this workshop. So some code Q&A. Then we will start building basically our platform. And after that, we'll start building circuits by connecting them to the platform. Now on Wednesday, we're going to play a lot more with circuits and measurements. And then on Friday, we'll do a few fun applications and then talk about the curriculum and resources that are available. And make sure you guys are all plugged into the resources so that you can get to, say, assessment materials and whatnot. So here is a picture of the kit that you received. And you also received some extra resistors that look like this, but are a little bit longer than the ones that were in your kit. Thank you, supply chain interruptions. We had to scramble to get the right resistors, and along the lines, a mistake was made so that the leads on these little parts were shorter than they should have been. And I'll show you where that comes into play in a little while. But anyway, so here is the kit before you put it together. And it's got the microbit, an adapter, batteries, alligator clip leads, lots of electrical and electronic parts, resistors, jumper wires, infrared sensors, LED lights, light sensors, push buttons. And they're the kind that you build on the board, because one of the questions that's going to come up for students is, hey, how do those push buttons really work? Well, they were built into the microbit, but you can also build them and connect them to the microbit to add a 3rd push button or a 4th push button to your application, or you can build up quite the large circuit like this. It's definitely a step beyond taking alligator clips and just connecting them to your microbit to build a single circuit or one or two circuits. And so this is kind of like a next step and a deeper dive into electronics and programming. Okay, so what we're trying to do is make it available so that it's a pretty good pre-engineering lesson for high school students, but experience has shown us that you can also use it more topically and do some fun things with it and essentially work with excerpts as opposed to going entirely through it step by step. I'll be focusing a little bit more on step by step, but we'll also talk about which ones are going to be good for the younger crowd and which ones we might want to think about skipping because they've got too much math in them. And I put in some links here to some documentation. If you've worked with other microbit things before, you might have seen the Python documentation, and then the Make It Code It site that I mentioned earlier with the beating heart. That's right here. And then some of all those little excerpts I took from, or all those little badges that you saw on an earlier slide are copied from and then linked to this page. So before I move on, are there any questions? Would anybody like to jump in and ask questions, make comments? Okay, well, we don't have 500 people. We've only got slightly under 40. So please feel free to unmute yourself and at any point say, hey, Andy, I have a question. I won't see you on the chat, but we have Stephanie Lindsay co-piloting, and she will be watching a lot of the chats and may end up bringing something to my attention.
Hey, Andy, can I jump in?
Oh, yes, please.
Hey, this is Brian Martin in Pittsburgh. How are you?
Hi, Brian. I'm good. How about you?
Good. I guess it's a curriculum question first.
Okay.
We've been using your basic stamps for a decade, probably.
Okay.
Do you see this? Do you see the Python and Microbit kind of taking the place of that?
Well, it's definitely a possible upgrade. So do you use the basic stamp in both circuit education and robots, or one or the other?
We do a quarter basis of about 66 hours, and we walk through about 6 chapters of what's a microcontroller. Then we move into the bot for about 2 or 3 weeks.
Okay, so let me give everybody else who's here just a little bit of background on that. So if we go to the Parallax website, and then do what's a microcontroller. So there is an older microcontroller, the one, this one right here, the basic Stamp 2 microcontroller that is used in the What's a Microcontroller kit. It's got a textbook, it's got a parts kit, and it's been around since roughly 2000, actually later 90s. And in different incarnations. And so this is something that he's been using. And then also the Bobot robot. Oh, actually, let me first of all just kind of expand here. So the What's a Microcontroller is essentially, it's a circuit introduction. And so what we are trying to do is provide a circuit introduction with the Microbit, which is a different microcontroller. It has some cool things built into it, like a radio and a compass and an accelerometer for step counting and direction finding and communicating with other microbits. So it has some really neat features that the basic stamp doesn't have. And so a lot of people are interested in taking advantage of those features in their projects, but also introducing some of the foundation that is, in What's a Microcontroller in terms of electronics and programming in that format. And so what we're trying to do is make it available through the What's a Microcontroller for a microbit. Okay, now I'm moving to the Bobot robot. I apologize that the search is seeming kind of slow here. It's probably because my computer isn't necessarily used to having so much going on with the zoom and the cameras and etc. So the Bobot robot looks a lot like the Cyberbot robot. And let's see here. Hopefully Cyberbot will appear in here. I'm going to open that one in a new window.
You get quickest results for stock codes.
Okay, Stephanie, could you call me out a stock code for the Cyberbot, please?
For the Cyberbot 32700.
Yeah, I don't have them memorized. Thank you. And we are on our way to 32700. Okay, so here is the Cyberbot. And here is the Bobot. And as you can see, they're rather similar. And there's a good reason for that. It's because there was a lot of success earlier on in the 2000s, especially teaching with the Bobot robot. Well, 2000 through today, it's still very much in use. The Cyberbot is essentially, it has the same material that is in Robotics with the Bobot, but it also has some extra material. So I'm going to go to learn.parallax.com. And we'll take a look at the Cyberbot, and I'll just point out a couple of things that are in the extra material category. I'll paste this link into the chat as well. Okay, so we are at the main tutorial page for the Cyberbot, and each one of these badges is a little booklet. And if you pile all these booklets on top of each other, you've got a rather thick textbook. But you know, divide and conquer. It's got everything separated into small pieces, which are conducive to classroom sessions. So some of this may look familiar. For example, writing programs with your microbit was part of the homework. And so, for example, solve math problems, you know, there it is. And so these are some prerequisites to the Cyberbot. Now, the Cyberbot and the Bobot have basically build it, make it travel in different directions. There's sense navigation by touch, some basic circuit building, the navigation by visible light, navigation using invisible infrared flashlights and infrared sensors to see what's ahead of you. So that's the main Bobot book. But because of the fact that the microbit has all these cool built-in extra things like the radio and the tilt sensor / accelerometer, what we have is some opportunity. Although it's called cybersecurity, there's a lot of groundwork here before we start doing the cybersecurity in terms of just doing robot applications and having open communication, something that is hackable and that you can make unhackable. And so, so we start with just radio communication, sending data, then keyboard control, where you have one microbit connected to the computer, and then another one that's on your robot, and they can be in contact via that radio. Then we start putting together the accelerometer and the radio with tilt control, where you can tilt one microbit, and then that determines how the robot goes. So those are kind of bonuses that are above and beyond the basic material that's available for the Bobot, because the basic stamp microcontroller does not have those built-in features. Then we take it a little bit further with cybersecurity activities that show how to protect information as it's being transmitted over an open radio channel. How is that for an answer? Is that okay?
That was a nice, that's pretty exciting, actually. We're so spoiled by your writing, Andy, that it's nice to have the two books handy and we can print them out. So I'm assuming from these little lessons you're making, we could print those off and make our own textbook. Is that correct?
Absolutely, Brian. It is Brian speaking, yes?
Yes, yes.
Okay. Yeah, so for example, if we go to navigation with the Cyberbot, okay, right here, this is basically the cover to this booklet. And right here is the printer-friendly version. And so what you can do, so what it's the way it's set up is so that you can, look at this page and then navigate to the next page like so, and then keep on navigating forward or backward. Okay, but in addition, you have your ability to go to different parts of the booklet just by clicking in the little contents overview on the left. Now, when you scroll to the bottom, if you're on that cover page, navigation with the Cyberbot, that's directly after I click here, let me just go back. Boy, it's because I probably, all right. Well, anyway, I clicked the link or the tile and ended up on the booklet cover here, and printer-friendly version right here. If you open that in a new tab, what that does is it unwraps, or it puts the whole booklet on one web page, and then you can go ahead and make a PDF and or physical printout of that. So I intended to talk about those features while we were looking at the at the what's a microcontroller, but it's basically the same idea. So all this navigation and the printer-friendly version will be there too. All right. And hopefully somewhere I've still got my slideshow. All right. So moving on, quick comment, since this is electronics education, since there's a lot of circuit building in there, just mentioning that it's kind of apropos with the reshoring and workforce development efforts that are going on in this country, that there's, and especially with the job shortages that we're seeing, that having students who have been exposed to pre-engineering and electronics material opens up a number of employment pathways for them, and it gives them a leg up in certain engineering programs too. So there's a lot of value to what we're doing here. This is for anybody who's watching this on YouTube later. So this is the homework that went out before the workshop started that most everybody has done. And in addition, these are the actual links in the slideshow notes. So you can catch up on homework. If you're following along with this video later, you can catch up on your homework here in the slideshow notes. And then this will take you to the actual video that shows how to, do the homework, getting ready for the class. So that's there as a resource, and you can either click the picture and follow the link, or just copy this link and put it in a browser. All right, so now let's jump to the hands-on activities. We've already gone through. Oh, actually, no, I gotta. Well, I think I'm going to, I planned on talking a little bit about the homework. I guess I should ask, first of all, did any questions come up for you on the homework as you were going through it? Is there anything that you wanted to try to revisit or? Okay, so it was fairly straightforward. Just going and seeing the programming pages, and yeah, the Python coding is something that is always going to take some time. And so in the interest of making this, 3 1.5 hour workshops as opposed to 10 or something like that, we're kind of doing a lighter treatment of the Python coding. But that said, let's go back to the Python coding lessons that you did. And so here we are, writing microbit programs was the first one. And so basically, all we did was go through and enter this script right here, and it displayed a little hello message on the microbit. And I'll just go through this very quickly, and please feel free to unmute yourself to jump in to either, say something or ask something. Remembering values. By the way, storing numbers, solving math problems, making decisions, and doing stuff repetitively are kind of the key things in any programming language. And so if you've got those down, you're ready to write code. And so we only did the first few examples, like saying, hey, here's a variable named A that we'll set to 42, and another one we'll name it C and set it to the character M. And then the D is a floating point decimal value. And then those got displayed. For solving math problems, we have something similar, except for this time we're just basically saying, hey, A is this and B is that, and C equals A plus B, and then we're displaying the result of C. For making decisions, now this is an important thing about Python right here, and that is that if you're making a decision, we haven't officially talked about the Python editor yet, but I'm going to just jump in there and do this one. Okay, so I'm pasting that in there. So the important thing to keep in mind is that when you're making a decision, when you see this if A is greater than B here, that whatever you're going to do as a result, if that statement is actually true, has to be below and indented from the conditional statement. So for example, if I wanted to do two things, they both have to be below and indented from. When you get to the else, which is if it's not true, that also has to be below and indented from. And so usually if you see a colon, you'll know that it has to be below and indented from. Also, if there's a point that you're curious about, for example, display.scroll, hey, what's that about? So this is an example of doing more than one thing in response to something being true in an if statement. And just remember, below and indented. Now, if you're curious about display.scroll, for example, there's a help button right here. That'll take you to the documentation, which I opened earlier. And then let's see here, display. Search docs, display.scroll. Okay. And so this shows all the places it appeared. And so hello world is going to be a very introductory thing. And then the MicroPython API is basically the full documentation of display. So those are resources. So remember that the question mark and then documentation can get you additional information if you open up an example program and aren't sure what it's doing. Let's see here, going back to the lessons. Okay, counting and repeating is another thing where you need to indent. So for counter in range 1, 11, that will count from 1 to 10, by the way. There's a secret rule that when you're using in range as you're counting, that it's inclusive of this guy and goes up to, but not including the second argument. So this will count from 1 to 10. And again, below and indented. Okay, so so these are things that we all typed in, and for best results, really, I always recommend to anybody who will let me bend their ear about it that if you're learning a programming language that is new to you, you will actually sit down and say, okay, I've got my editor on the right, I've got my code on the left. You can swap them, no big deal, whatever is most comfortable. But the idea is that you want to have your textbook and your coding environment side by side and actually be typing in the entire thing. However, after a few times of typing the program name and from Microbit import, that can get a little repetitive. So after you've done it a couple times, you can say, okay, well, I'll copy that part. Okay, but this counting business is new to me. So I'll start typing for counter. And I also recommend talking with your students about this because it really, you know, typing in the code is a way to have it really sink in better than just reading it. So, it will help improve your students' ability to ascertain what's happening with the program. But you know, I don't recommend repeatedly typing something if you've already got it memorized, but I do recommend typing anything that's a new concept at the time. And so this way we can say, okay, well, let's go ahead and try it out. And I will talk about some of these, some more of this later. So I tried this out and now need to get to, okay, let's. Well, that's interesting. So I tested this out beforehand and the display looked nice and clear. 1, 2, 3. Oh, here we go. 1, 2, 3, 4, 5. Hopefully that's visible to you viewing it as well. Okay, good. I'm getting some nods and thumbs up. Excellent. So the idea here is that we have this feedback of what the program did. So after putting them side by side, typing in the code, you'll want to you know, test it out on the Microbit, make sure it does what you expect, resolve any inconsistencies between what you expected and what it actually did, fix bugs if you made a mistake like this. And by the way, so let's say that I have a mistake. Instead of display, I misspelled it dislay or disarray or something. Okay, so when I try to run that, what happens is, trying to get back to the screen, I'm going to restart this. So you'll see a frowning face. And then you'll see a message that's very challenging to read. So here's a pro tip, and that is, instead of trying to read the Microbit's explanation for the mistake you made in your code, you can click the Open Serial button. And when you do that, it says that there's an error on line 6 and that it doesn't understand to say. And then the student can have the aha moment much more quickly that they didn't type in their code correctly. So I hope you find that helpful. So remember, open serial, and then if I flash it again, hopefully I actually corrected the problem. So now there's nothing in the terminal, and then if we go back over to the window, it's counting again. All right, there we go. Okay, so that's the programming, and it is something that we won't have time to cover in the workshop, except for lightly like this. I do highly recommend going through the stuff that your student's going to learn and making sure that you feel comfortable with the material before presenting it to them.
Andy, we have a question.
Okay, one moment.
It's just a quick one.
All righty, go
about
ahead.
Why it's called Open Serial.
Why is it called open serial? Well, serial communication, definition-wise, is basically sending a sequence of characters or a sequence of values from one device to another. And so the microbit is communicating this serially over the USB, where it's sending the value that corresponds to, like if it's hello, it's sending the H in hello, and then it's sending the E in hello, and it's actually sending the numeric code called an ASCII or ASCII code that represents each of those characters. And so it all goes across the USB cable as electrical values that correspond to binary zeros and ones. And at the computer end, it takes all that data, puts it back together, and then shows you an H or an E or an LLO in the terminal. Does that suffice? So the data is transmitted and received serially or in sequence. And so, so when we say open serial here, we're opening a terminal that displays data that was received serially from the microbit, and that you can send serially to the microbit if you click this and type it in, and assuming that your microbit has some code in its script that is
I will take it that we understand, given the messages says, thank you, I prefer Captain Crunch myself, and on my fave, followed by thumbs up for Crunch Berries.
Oh boy. All right, well, thank you for that. Count Chocula for me, please. Actually, probably should settle for oatmeal, but anyway. Okay, so here we go into the hands-on. Now that we've talked about some of the code stuff. So this is a list of all the links we're going to visit today. So you can click any of these. For example, the all-important first one is learn.parallax.com. And so, but what I did was I broke this all out into individual slides, which I think will have some benefits simply because you can see the slide, what it's supposed to look like, and you've got the link. Especially for later, I want people to be able to see the links and to be able to get to these various pages. And so that's why I have it on a slide, so it'll be visible and accessible. So the first link, as I said, is learn.parallax.com. So I'm pasting that in. And this is going to be your entry point into any of the lesson sets that we've got, be it for, that we have 4 different similar robots that are like the Cyberbot I talked about. We have couple of different what's a microcontroller kits. Somebody mentioned the Scribbler 3 that they were using in their class. So these are basically all the textbook entry points for our different pieces of hardware that are used in the classroom. Like here's the Cyberbot, and then here's what's a microcontroller that we'll be using today. So I'm getting ahead of myself. The next slide is that. So here we go. I'm going to paste these in just for convenience for all those of you attending. And okay, so here we are. Again, this is the this is our stack of booklets for this class, and there are plans to increase the number of booklets that we have. Currently, we have through servos, and I'm working on the potentiometer chapter presently, and we'll be working out of the draft of that. So again, writing microbit programs was something that you went through as the homework, and also computer and microbit talk, where you used the serial terminal. Then what we're going to do next is put together our platform. And so this is the page we'll be starting at for this. So this is breadboard setup and testing right here, and this is something that the students are going to be doing later in the lesson. The cover page talks about the parts you need and some of the things that you're expected to know going into it. And then we've got the contents, and we can move on to the next page. And this page starts off with saying, okay, this is what it's going to look like when you're done. And then there's some kind of interesting introductions, like this talks about what are the major parts of a breadboard, and how do those little numbers and letters along the top and side allow you to call out a "you sunk my battleship" socket. For those of you, hopefully, I don't know, how many remember Battleship? All right. So anyway, yeah, the breadboard has those same coordinates, and so instead of using 1,000 words or 1,000 pictures, we're now using animated GIF files to try to get this across in an alternate channel. So we do have it explained in words up here, but we also try to get it across visually as clearly as possible. Okay, so what I'm doing now is I'm just paging through the booklet, and each of these is going to be a slide. And so since there was just commentary on that, but no action items, I'm not going to paste it in. However, this one, I believe we're going to want to paste in. So this shows the parts together, but don't gather them yet. Stay with me for a minute here. I want to point out that in addition to the animated GIF, which you don't have any control over, there are, for most of these animated GIF files, a video that you can play and stop and navigate. So there's an MP4 link that's just above. I hate saying GIF because it's .gif, but I was told that that is the way it's pronounced, as GIF.
I've been saying GIF all along, so now I'm
yeah. Well, you know what? If you don't mind, I'm just going to say GIF because I can't help myself, and it doesn't sound right anyway. Okay, so
it's a peanut butter.
Yeah, to go with our Captain Crunch serial communication. Anyway, so here's the animated GIF, and but when you're trying to follow this, it replays relentlessly. So what I did was I right-clicked and select open a new tab. And here we have an MP4, which you can, say, okay, well, I'll just pause it right there. And then I'll put my microbit together with the Edge IO adapter. And then I'll go ahead and hit play and go, oh, now I'll go and fish out my breadboard. And then it's showing, okay, look carefully at these parts, and it's showing you exactly where the pins that are sticking out of under the bottom of the adapter which sockets are supposed to receive each of those pins. And there's also written information that's saying, okay, everybody line them up very carefully. And then we have this visual aid here to help people line them up carefully. And then once you've got them lined up, it gets across that you need to sync those pins as far as they can possibly go into the breadboard. And so those are all important steps that this animated GIF and its accompanying MP4 file, which you can pause, are reinforcing. So now I'm going to paste this into the chat. And I would like you all to go and fish those parts out of the box, your kit, and attempt to follow either the animated GIF or the MP4. Oh, looking good. Some of you I see already have it going. So I'm going to do that now too. And I'll kind of be watching to see when heads start popping up. So actually what I'll do is so I'd like all of you to attempt to do it from the MP4 file. And but you're also welcome to watch me. I'll just on screen do it so that we have an idea of when we might be ready to move on to the next thing. So here is the Edge IO adapter from the kit. And the idea is to carefully line up the pins that are sticking out of the IO adapter so that the one labeled P0 right here lines up with A30, the A30 socket right there, and everything else should kind of follow. And then once you've got them lined up, you can go ahead and press very firmly until the IO adapter sinks all the way in. I might be doing this slightly out of order, actually. Then we've got our microbit, which when I unplugged it, my video froze. And I think that it'll unfreeze in just a second. Wow. Okay, I want to be careful not to do that. Yeah, you need to make sure that I see from the chats that someone, Diana, didn't hear it snap in, and it is true that you need to really use some force. And in fact, you know, yeah, sure, I showed you for the sake of demonstration, I squeezed them together, but it's usually better to put them on a table and then use your thumbs to press it down nice and hard. And then what you want is for this the black headers that the pins are sticking out of, it's a plastic part at the base of the pins, and you want to see that up against the surface of the breadboard there. Okay, how are we doing, everybody? All righty, looking good. So next up is first electrical connections. Now, I actually forgot to make sure that all of the MP4s are up. So I'll be assigning a little bit of homework between today and Wednesday, and I'll assign myself to make sure that these all have MP4 links, although this page should not have an MP4 link because it is just the cover page. So I'm hoping that there is an MP4 link when we get to the actual page where this is discussed. So this I know to be one of them that does not have an MP4, but that I want to have an MP4. So and I also located said MP4 file. So these are things that you can use, again, hopefully as an aid to talk with your students about, the basics of how a breadboard works. And that was actually the wrong file. Let me see if I can. Sorry about that. Okay, so here we go. So this is another thing where I'm hoping that you can use it as a play and pause thing to talk with your students about, in this case, how electrical connection works. And the rule for these breadboards is that on these terminal strips, which is the main area here, the A through J and the 1 through 30, all of these little holes right here, if you want to connect 2 or more leads together, they all have to go in the same row of 5 sockets. And so we're showing here, we put the two wires in, and you can say, all right, is it connected or not? Well, let's find out. Yes, it's connected. So then we have another wire in another row. And the question is, are those 2 yellow wires connected? The answer is no. But if we plug in another wire into that same row, are those 2 connected? The answer is yes. But what about these 2 blue wires? Are they connected? No. See, and it's there to reinforce that you want to be in the same row, that it only matters if you have 2 things in the same row, or 3 or 4 or 5. All the things that go in that same row of 5 are connected. And then it goes on further to show that, hey, if you pick a different row of 5, even if it's the same overall row, that the wires on the opposite sides of the valley are not connected, because we're only talking about rows of 5, not rows of 10, but you can make it a row of 10. And then you do have connected wires, because there's this part, and I have a nice visual aid for that somewhere nearby. Yeah, I think I might have skipped it. There is a picture of a disassembled breadboard, so that, and we talk about that there's a metal underneath each of these rows of 5. And also we have columns in between the breadboards. And so we do the same set of lessons there with, okay, the column by the red plus line allows you to connect stuff. The column by the blue minus line allows you to connect stuff. And you can even run a jumper wire between 2 blue minus lines so that you can make a much larger connection that happens to be adjacent to all the rows that we're going to build circuits in, which means that if you need a common connection like 3 volts or the negative terminal of your battery supply, they're right next to any circuit you're building. All right, so So let's see here. Yeah, so then we're on to putting together your probes. And these probes are going to be used to actually test those connections, but it's going to be a lot more than that. So I'm going to paste you this page, and then I'm going to paste you the link. So what we're going to do is not just build a light circuit and make it blink or watch it. We're actually going to do measurements of said light circuit, and we're also going to do measurements of whether or not two wires are connected via a row. And so let's see, I am looking for the chat window. Here it is. Okay, so that's the page we're on. And then here is the MP4 link. So I'll have you guys go ahead and pause the MP4 or just watch the repeating animated GIF to build up this circuit where you've got some alligator clip probes. And you have that in your chat, so I'm going to do it in real time also. Okay, so we are using the red and black alligator clips. And you also need to dive into your bag of parts. I'm going to upend my bag of parts slightly aside from the breadboard. And so these are 3-pin headers right here. That's what they look like. And so I'm going to, from my alligator clips, remove the red and the black alligator clips. And so that gives us our alligator clips and our 3-pin headers. And the 3-pin headers are connected to the left breadboard. Let's see, now I don't remember their exact position. Okay, yeah, so C through E. So row 1 and row 3, C through E for the alligator clips right here. And then, or for the 3-pin headers, pardon me. And then we'll go ahead and grab each of the 3-pin headers by squeezing the alligator clip to open it up, and then let it close on and basically chomp on that 3-pin header. So there we have it. All right, I see some heads still down, so I'm gonna give you some time.
I'm sorry, Andy, can you do that again, please? I took a restroom break.
Oh, of course. All right. So the main thing is now the best way to do this is going to be, I'm going to chat you a link to the video clip. Or would you rather have the video clip to work from, or would you rather have a live camera version? Which
I like watching you.
Okay. coming up. All right. So, so presumably you've got this already. Is that right?
Correct. I have all that.
Okay. So the thing to do is going to be to fish your red and black alligator clips out of the box. They look like that. And another thing you're going to need to fish out of a bag of small parts. Looks like that. It's got that label on it. And it's got a bunch of small parts. Here's a sample. So those are some of the parts that are in there. And what you're going to do is you're going to want to, or what you're going to want to find are these little 3-pin headers are what they're called. Now, once you've got those 3-pin headers, let me know.
Got them?
All right. So, and do you have the alligator clips too?
Yes.
Okay. So next up is to basically, do you see where it says, looks like the video is not catching up with me. The video froze. Oh, good. Okay. Do you see where it says P0 right there? It's kind of hard to see, but if you look at your own, you'll see P2, P1, and P0 as the bottom. Yeah. Okay. So the same row as P0 is plugged into, it should be row 1 on the breadboard. You'll take one of those 3-pin headers and insert it into the C, D, and E sockets. So row 1, columns C, D, and E should have one of the 3-pin headers plugged into them.
Got it. Thank you.
All right. And then row 3, C, D, and E, that's going to be next to P2. So P0 and P2, the row, so row 1 is where P0 is, and row 3 is where P2 is. And go ahead and connect the 3-pin headers to those 2 rows. You want to plug them all the way in so that it's down to the plastic housing that the pins are passing through. And then once you've done that, connect your black alligator clip to the row 1/P0 3-pin header, and then connect your red alligator clip to the row 3/P2 3-pin header. And then you have a nice little multimeter device once the Microbit starts participating in this game.
We have a question about your GIFs and MP4 resources. I know that you use CorelDRAW for the basic drawings.
Yes.
But what do you use to turn them into your GIF and MP4 resources?
Okay, let me think about this. Yeah, to get the images, I use CorelDRAW for the basic images, and then I apply circles and arrows often in Microsoft PowerPoint. Whenever I'm recording using Camtasia. It's TechSmith is the company that makes it. They also make Snagit, and those are, I usually like to go with freeware whenever I can, but boy, I feel like even on my personal computer, I have both Snagit and Camtasia. They're just excellent investments. They're really a good value. And so, yeah, that's where I do my recording. Snagit can do GIF recordings, but it does not save enough space. Camtasia has all these nice space saving features so that you get small files. And we need those for basically our website so that it doesn't slow our website down too much. All right. So the next thing I'd like to do, oh, by the way, I currently have a bug in the software that I need to work on. So right now, we're not going to have any beeping noise when you're testing for continuity, which is the fancy name for testing whether you have an electrical connection or not. And but you will see either a check mark or a circle with you will see either a check mark or a circle with a slash through it, indicating not connected. So the first thing we want to do is download continuity tester.hex. When we're taking electrical measurements, I decided to make that not a programming challenge, because when you're using a meter that maybe looks like, oh boy, I lost my meter. Here it is. Okay, so we're making the microbit mimic the behavior of a meter like this. This is a multimeter, so you can measure voltage and resistance and electric current with it, among other things. And so one of the things that this multimeter does is if you're testing to make sure that two wires are connected, it will beep. But in this case, it's just going to display on the LED matrix display, and it'll show you a check if it's connected, or a circle slash if it's not. And let's see, I need to copy now the, and so because of the fact that there's something that you can just grab, that being this multimeter, and it's ready to do the job for you. So this multimeter is just ready to go when you use it. To try to get us close to that, what I did, as I said, is I set it up so that it's decoupled from the circuit building and the programming. It's just, hey, download it, run it, and then view the results. So here is the link address, or actually, I'll show you what this animated GIF is showing you, which is basically that you want to go to this page, which I'm pasting into the chat. And then you want to right click and select Save Link As this continuity tester.hex file. And when you do that, it'll ask you where you want to put it. And I want to put it in downloads. Save. Okay, then it should be visible on the lower left as a download, continuity tester.hex. Then this animated GIF is showing you that you can go to python.microbit.org, which I'll paste into the chat also. Okay, so has everybody downloaded continuity tester.hex? Excellent. All right. So then what I want you to do is continuity tester.hex is now down here at the bottom left. What I want you to do is just drag it and drop it onto your python.microbit.org editor pane, and it will open up continuity tester.hex and display the code for you. Okay, how are we doing, folks? Everybody got it open in their editor? Okay, stop me if I'm rolling over you while you're still working on stuff. So next, we'll need to connect our microbit if it's not connected. So you'll want to connect it with a USB cable to your computer. And when it does that, if everything's going right, it should open a Windows Explorer or Mac Finder or I forget what the file browser is in Chromebooks, but basically it should show you a microbit in your file browser. That way you'll know it's connected. And then once it is,
Andy,
yes.
Did you show the right clicking of that to get it to download instead of clicking on it?
Oh, I hope so. So continuity tester.hex. What you want to do is you want to right click, select save link as, and then download it to downloads. Now, some of you, especially I've noticed a couple Macs that that don't cooperate if you just drag and drop your downloaded file into the editor. If you see that problem, here's how to open it the more official way. Click load save, then click or browse for file. Then you can go to your downloads and open up continuity tester.hex. Is everybody good? Okay, now we'll load the code into the microbit. Click connect. And then it'll give you a list of devices. I only have one. Hopefully all of you just do have one also. And then it'll show you, it'll give you the disconnect option, and it'll show you that it's connected as the icon smiling. And so then you're ready to click flash to load the program into your microbit. And once you're there, so now at this point, I've got a circle with a slash through it on my microbit's LED matrix display. And that's because these two alligator clip probes are not electrically connected to each other. Now, fingers crossed, if I grab them, if I open them up and have them chomp on each other, they are now electrically connected to each other. And note that at least most of the time I have the check mark showing that we have electrical continuity. Now, the other thing that we can do is grab a couple of those jumper wires, and I would recommend a black jumper wire. Actually, I think I forgot to include this step, that it was in the video, but not in the but I didn't do it. So what I do is I grab the end of a red wire from my parts kit with the red alligator clip that's connected to P2. And I grab the black wire with the black alligator clip that's connected to P0. And what that allows us to do, now you can pick a row of 5, like I'm picking row 17. And I plug the wires into row 17, just as we want students to do. This is by the way, step-by-step of what we do in the actual web page as part of the booklet. And there's little red check marks on the page that are actionable items that students follow along and do. And so this is one of them. And then it says, okay, we'll try a different row of 5 sockets for one of the probes. And now it's showing that it's not connected. And so all those animated GIF combinations that I talked about earlier, the students are prompted to go through those and test, and they're also prompted to test the columns so that they can see that, hey, when you're along yeah, I think I have a little bit of a tenuous connection with one of my alligator probes. I don't like the way that's flickering. I'm going to have to. Take a look and see why that's happening. Are most of you getting a check mark when you do either the red or the blue column? Okay, so did everybody get a chance to try a few connections along with me, or are we looking good there? Okay, I'm getting nods, thumbs up. Excellente. Again, unmute yourself and say.
I'm getting web USB error.
Ah, okay. Thank you for speaking up. I was beginning to worry. All right. So web USB error. So, okay, I'll disconnect. So if you try again, so go ahead and OK out of your web USB error and click connect again. Does it show you, does anything different happen the second time you do it?
It immediately goes to web USB error again,
Okay.
almost instantaneously.
Okay. So check, unplug and replug each end of your USB cable.
Hey, quick question. Can you hear me?
Yes.
What type of volts should we be getting? About 3.25?
Yes.
Okay. Thank
Roughly 3.25 is good. 3.3 is in theory what it's supposed to be, but it's not going to be exact. So,
Okay.
you know, plus or minus 0.1 volts is good. And 3.25 is right in there.
Just like a resistor, plus
Yep.
or minus. Yep. Thank you.
Yes. Okay. You're
Hey, if
welcome.
I have to take off to get my little girl, I could watch this later as well on YouTube.
Absolutely. I'm going to get it posted and send it out as
Thank you.
quickly as humanly possible.
Yep. Thank you. Everything's good.
All
Thank you.
righty.
It's connected now that I've unplugged and replugged everything.
Okay, good. So now have you got the code in there? Can you hit download now? Or I'm sorry, can you hit flash now?
I did, and it gives me a web error again.
Okay.
It's
Yeah,
all
so
good.
we'll,
I may have to restart some things.
yeah, and then also, can you make sure to email me? So we've got an email chain going on, because what I can do is do a tech support session after class.
All right, sounds good. Thank you.
You're welcome. But one other thing is that you can, all right, so if we're disconnected here, when you plug your microbit in, you should have a file browser that looks like this. And you can actually drag up. You can actually drag continuity tester right into your microbit when it appears on the file browser. So this is the microbit. It looks just like a USB flash drive in your file browser. And basically after you've done that, it disappears and reappears. So again, you can go to downloads and then drag continuity tester into your microbit flash drive looking thing, and that'll load it.
Andy,
You'll need more than that though for some of the future activities.
we have a question.
Yes.
The question is, what does SLEEP stand for?
Okay, what does SLEEP stand for?
And maybe it's a good time to show where the API reference.
Yeah, so SLEEP. So if we go, so this is an example of, hey, you're looking at some example code and something doesn't make sense. In this case, we're looking at SLEEP. So you can hit help, select documentation, and type in SLEEP. And you get a lot of different answers. And I'm looking for one that is just sleep. I mean, I know the answer is in the API reference. I wish that, so Control F, sleep.
If you put in sleep function, would that
It
narrow the
might,
search?
it might. Let's try that. Good idea. Well, okay. U time for microsecond time sleep. Oh, well, maybe it was the first result. I don't really like the way they've documented this. I mean, I'd like to have a simpler thing. I think that you would run across sleep in some of the tutorials, like
Try the second result you had there.
okay.
If you go back to the search,
Thank you, Stephanie. Oh,
it was right under your nose.
yeah, it was. I also never try to solve a math problem when I'm presenting earlier, because for some reason presenting disables my ability to do any kind of math. Anyway, no future as a math teacher, I guess. Microbit module, and then here is microbit.sleep, and it says wait for n milliseconds. Those are thousandths of a second. So it may take some clicking around if you're answering the question on your own, but the answers are going to be there with some digging. All right, so let's quickly build our first circuit. Now we want to leave this circuit on there. So we've done some testing of various connections. Oh, actually, what we need to do is connect our power wires here. Copy link address. Okay, so I'm going to paste in this page to you. And so basically, I unplugged the alligator clips. Don't unplug yours, but especially always leave behind these 3-pin headers, because we're going to disconnect and reconnect the alligator clips periodically to measure stuff. So what these 4 jumper wires will do is give power to your board. So, and I'm going to give you actually the parts and circuit page. That was the page I actually meant to give you. There we go. And so the circuit shows exactly where to connect. And then I'm going to leave this thing with the magnifying glass up and even give you a link to it so that you can double check your board. So that's a video showing where to put all the wires, and then you can use the, then you'll want to look very closely to make sure that you've got your connections just so. And I'll zoom in on this so that it fills the entire screen. There you go.
Andy?
Yes.
Yeah. So considering we're working with students who are new with electronics and circuits in general, does the microbit include features that make it robust, for your short circuits, over voltage, over current, that kind of thing?
Yeah, the microbit is quite handily difficult to damage.
Okay.
So yes, it has protections so that essentially, most of the reports I've received from teachers are that it's hard to break the darn thing, static shocks and, dropping on the floor and various other student abuses just don't tend to phase the microbit. I'm not saying that it's impossible to break one, but they are nice and sturdy and work well in the classroom from the standpoint of durability, as opposed to a kind of high performance microcontroller where you might actually need an anti-static mat and bracelet to safely handle the thing without damaging it. That's the opposite end of the spectrum from where the microbit is at. All right. So how are we doing? I'm seeing some foreheads still down. So everybody's still working on it? Yep. Okay, so I've got some thumbs up, and I'm going to let everybody work for a little bit longer on this. So I think what we'll conclude with today is actually just testing the light. So we're going to build a light quickly in the last couple of minutes. I'll give you a circuit schematic. Now, normally we have folks disconnect their power, but we're going to go ahead in the interest of time and hot socket our microbit. So normally we would disconnect the USB power, but I'd like you all to first check and make so normally we would actually disconnect. Normally we would check for 3 volts and 0 volts there, and in fact, I'm going to do that instead. I want to err on the side of caution here. So what we'll do is test our circuits with this measure volts copy and then paste. All right, so we're going to open this measure volts script. Now remember, find measure volts, right click it, and select save link as. And then after you've downloaded it, open it in your Microbit editor, your python.microbit.org editor, and then load it into your microbit. Okay, so while we're waiting, mine is taking a little bit longer to load in. So while we're waiting for mine to load, let's take a look at how to measure the voltage. So again, this is going to be something that that is shown in detail in the tutorial pages. But basically, once you've loaded the measure volts script, we'll be able to display it, but we want to make sure that the voltage between the black wire that's plugged into a socket by the blue stripe and the red wire that's plugged into a socket by the red stripe, when we connect our alligator clip probes as such, we want to get a 3-volt measurement from that, roughly 3.3 volts. So now that I've loaded it in, I'm going to go to Open Serial. And the voltmeter is saying 3.28 volts. So for me, that means I did not make a wiring mistake. So I'd like all of you to verify that that you've got 3 volts across the middle bus strip and the right bus strip. bus strips being the vertical columns of, so right now I'm plugged into the right bus strip. Right here. And then if you can verify by clicking Open Terminal after loading, after flashing the program that we just downloaded, if you can verify that you've got 3.28 volts there, that'll be excellent.
Andy, I got all kinds of numbers. I got 71, 81, 86, 91, 54, 64, 74, et cetera, et cetera.
Yeah, so that means that something's not well connected. What we can do is, I want you to, I think the best thing to do would be to check your alligator clip connections, make sure that they're plugged in at both ends.
Oh, yeah, no, I don't have them plugged in. Where are they supposed to be at the other end? They're not
Okay.
plugged in anywhere.
So the alligator clips should be gripping the 3-pin headers at one end.
I do?
Yep. And then at the other end, they should be gripping the wire ends.
Oh, yeah, I didn't do that.
And then you want to plug the other ends of the wire, one in a socket right by the red column, and the other in a socket right by the blue column.
Oh, I messed up. Okay, thank you.
Yeah, no problem. Folks, if
yeah.
you can hang with me for just a minute longer, there's a question. Yes. Hello?
Yes. Oh, not me. Bill? Is that you, Rich?
Okay.
Someone was about to say something and I interrupted.
Yeah, go ahead and say something.
Oh, I maybe it was me. I do have a question. I started. I didn't want to interrupt anybody else. Okay. Maybe it was me that you heard starting to ask a question. Could you show the code again for the voltmeter?
Yes.
Please?
Now, we don't want to have you typing it in because it actually, there's something called a module underneath this, but this is what the code should look like.
Okay. Okay.
I do have a question. What it looks like Rebecca was reporting she has 0.62, and I'm wondering if anybody else did not get something between 3.25 and 3.3 that might need some troubleshooting.
This is Rebecca, and I finally did get it to, I moved some of the pins around, just making sure the connections were good. But now it seems to be jumping between 3.29 and then it'll go down to like 2.9 and then it'll come back up. Is that normal?
Yeah, that may just be still a loose connection, like that the pin, the alligator clip jaws are not gripping the wire ends quite well enough, or possibly something on the 3-pin headers. But I think you're probably good. And then the thing to do would just be to check the middle columns as well. So so these guys right here. So if you put your red and black probes, hopefully my display will update here in a second. But essentially, yeah, there we go. So we want to probe the middle column and make sure that it also is giving me 3.28 volts. And then very quickly, I have a little bit of homework for you all. And I will send out an email about the homework too.
Okay.
So the homework is going to be a few things. First of all, I just want to make sure you can find this battery holder in your kit. And there should also be 2 green batteries. and then again, this is for homework, not necessarily this instant. You'll be finding a device called a push button. And this push button has little legs coming out the side of its case. And you'll be building this push button circuit. And when you do so, you'll want to make sure that the buttons are sticking out the left and right sides of the case as you insert them into the breadboard, not top and bottom, left and right.
Okay.
This will be the circuit you'll build. There will be 3 green lights and 2 push button circuits. And I'll send you corresponding links too. And I just lost my mouse. Let's try the keyboard. That froze. Well, there was a schematic on the next page, but I can't show it to you. I'm hoping you can all still hear me because I'll be emailing you. It looks like Zoom froze. I'm waiting for it to unfreeze.
I can hear you at this point.
Okay, that's luck. Can you still hear me?
Yes, I can.
Excellent.
Yes.
Oh, good. Glad to hear you, Rich. I think that's Rich, right?
We can see and hear you. You're still
was
moving and talking.
Okay. Well, that's good. So this homework I will go ahead and send out to you to build this circuit, and then we'll continue where we left off. And I'm still waiting for my Zoom to unfreeze. I'm glad it waited till the tail end here. Are there any questions while we wrap it up? And also, would anybody like some additional support? Like, for example, any of you who have tenuous voltage readings, if it was flickering between 3 volts and some lower value, we may want to take a closer look at that. If you could email me, we can set up a time to just quickly meet over a Zoom and look at your board and your alligator clips, and possibly swap out with different alligator clips and see if the problem goes away, things like that.
Question here, is there any damage to the bit if you just disconnect it, or do you have to eject it like you do a USB drive?
There's no damage. You can just go ahead and unplug it anytime. And the emphasis there is you can unplug it from the computer and it won't hurt your computer or the microbit. At least I have not had any reports at all of problems on either end.
Hey, Andy, where do I plug the opposite end of the alligator connector? Where do I'm sorry, I'm behind.
Oh, that's okay. So you have the ends that are on the 3-pin headers, right?
Yes, I got that.
Okay. So then have you grabbed a wire, like with the red alligator clip? Have you grabbed?
Yeah, I did the red. I just need to do the black.
Okay. Yeah, good. So then grab the black wire with the black alligator clip. And then locate a column of sockets next to the blue.
I lost you. Are you there?
I think he's lost his connection. Yeah, it looks like he's frozen. He may try to get back in a minute. We've pretty much completed today's presentation, so anyone who needs to go is welcome to go if you want, and we'll be sending more homework tonight. And if you want tech support with anything, you can email Andy directly and he can arrange to meet with you one-on-one if you are stuck and don't feel like you can go forward without getting unstuck.
Okay, thank you. I'm going to hold on a second in case he comes back.
Sure.
Okay,
and
thank you. Have a good night.
Thank you. Thank you very much. And I am also trying to look for the link to the exact page that will show you where to put all the wires for your continuity test that Andy was working with you on.
Thank you. Appreciate it.
You're welcome.
he shared shows the circuit.
Here we go. It's on this page.
Somebody said the PDF he shared shows a circuit. I'm just trying to find the PDF.
I am sending you, I just sent a link to the photo we were working on.
Oh, awesome.
Okay,
Thank you.
yeah.
So I can do this on my own. Cool.
Yep, the whole tutorial that I sent you the link for is a subpage in breadboard setup and testing for Microbit. And you can just, if you want to just go back for review to catch up wherever from where you were, just start with the first electrical connections with the breadboard and go through step by step.
Awesome.
Yeah.
Thank you so much, Stephanie. I appreciate your hard work.
Oh, you're very welcome. Anytime you see a red check mark on one of the pages, that means it's time to do the action.
Okay. Thank you so much. I'm going to go ahead and drop
you.
off then.
Okay, thanks. Have a good evening.
Take care. Bye-bye.
Goodbye.
Hey, Stephanie, are you still there?
I am still here. I am chatting Andy via Google Chat since he's still trying to be present and cannot get back in apparently.
Oh, okay. I just sent you a chat about the extra resistors.
Yes, I did. Well, the resistors that were supposed to be extra was supposed to be a ribbon of 220 ohm resistors.
They're 220s? Okay.
Yeah, there should also be 220s in the kit, but for some of them, the leads were trimmed too short. And so we just were supposed to have a strip, you know how sometimes they come mounted on in a reel where there's a paper strip that connects the ends of the leads in a row so they're all lined up. We were supposed to just have an extra strip in there for you, but if that didn't arrive, our apologies. And hopefully the 220s in the kit will reach where you need them to. If they don't, you can always use a jumper wire to connect where two pieces in the same row and jumper over to where it was the other end of the resistor was supposed to go.
Okay. Yeah, I just want to know what size they were, so I'll just grab some at school.
Oh, good. If you have a stash, that'll work just fine.
Okay. Thank you so much.
Okay, you're very welcome, and we'll see you Wednesday. Andy cannot get back in, so we're going to go ahead and end the meeting, the recording and the meeting now, and we will see you all on Wednesday.